Alright guys, today we're going to be talking about parallelograms, and that's the chapter 8, and at the beginning of the chapter we don't dive right into parallelograms, but we talk about polygons, and polygons is a term we've used in the past. Poly means many, gons meaning sides. So to write the definition for a polygon, it's a closed figure formed by lines can't spell lines, that do not intersect more than twice. Okay, so to give pictures to the definition, these are polygons. A triangle, Patrick star, a trapezoid. Every side connects with two other sides, but not more than two. These are not polygons. A circle, you can't have curves. That's not a line. It can't have a curve anywhere in it, or it cannot have lines that go crisscross, such as that. Okay? So those are not considered polygons. Now, we can classify polygons into two different types, convex and concave, and these are opposites. A convex polygon, no points are located in the interior. No points are located in the interior. Okay, so for an example, a triangle is convex. All points or vertices are outwards. A parallelogram is convex. A trapezoid is convex. However, in a concave polygon, it has a point, or it just has to have one, or it can have several points inside, in the interior. So it has a point in the interior of the polygon. Alright, so Patrick star, he is concave. He caves in because we have points that are inside, such as these. They point inwards. You could draw a pentagon. Instead of going up, you go down. That's concave. An arrow would be concave. Alright? Then, a regular polygon. Regular meaning all sides and all angles are congruent. So all angles are congruent, and I'm using my symbols. All sides are congruent. It doesn't matter how many sides or how many angles a polygon has. As long as they're all congruent, then it's considered regular. So a triangle, a regular triangle, we have a special name for that. We call it equilateral. We also call it equiangular, because if all sides are congruent, then all angles are congruent. A quadrilateral, a four-sided regular polygon, we have a name for. We call it a square. All angles are 90 degrees, and all sides are congruent. And you can have a regular octagon. A little trickier to draw, but give it a shot, trying to make all sides the same. My drawings, as you know, are not anything elaborate. They're actually pretty horrible, but hopefully you can get the idea. Okay? Now, we have two different types of angles. We have your interior angles and your exterior angles. And an interior angle is an angle inside a polygon. And an exterior angle is an angle formed on the outside of a polygon. Okay, so let's draw pictures of each of those. I'm going to draw a special right triangle, a 30, 60, 90. Y'all love those so much. Okay, I have 3 interior angles. They're all the angles inside. Okay? And I have the same number of exterior angles as I do interior angles. So if I draw the same triangle, give my 90 degree, my 30, and my 60, okay, I am going to extend the sides. I'm going to do it with a dotted line, and I've just created an exterior angle. Then I'm going to take this side over here, and I'm going to extend it out, and I've got another exterior angle. Then I'm going to take this side and extend it out, creating a third exterior angle. And this is going to be important later on. Notice the exterior angle is adjacent to the interior angle. And we'll be discussing that on the back side of the notes. So you have 3 exterior angles and 3 interior angles in a triangle. Now on a quadrilateral you have 4 angles. So you have 4 exterior angles. In an octagon you have 8 interior. You're going to have 8 exterior. So however many interior angles you have, you'll have the same number of exterior angles. Alright, now we're going to kind of fill in this table, kind of classifying some of the different types of polygons, convex polygons. We name polygons by the number of sides that they have, and that's what we're going to do. This column here tells you how many sides there are. We're going to give it a name. 3-sided polygon is, of course, a triangle. 4-sided is a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. 8, octagon. 9, nonagon. 10, decagon. Can't spell decagon, D-E-C-A-G-O-N. And 12 is a dodecagon. Now, for anything else, we give it a generic term, an n-gon. N meaning the number of sides. So however many sides it has, if it has 13 sides, it's a 13agon. If it's got 25 sides, it's a 25gon. If it's got 142 sides, it's a 142gon. That's it. It doesn't get any fancier than that. Alright, now then, this column represents the number of triangles that a polygon has. And you might be thinking, what in the world does that mean? Well, when we're looking for how many the sum of the angles, the degrees of angles in a polygon, this is another way to do it. We all know that a triangle basically is one triangle, and it has a total of 180 degrees within it. And we also know that a quadrilateral has 360 degrees in it. But did you know you can create 2 triangles out of a quadrilateral? And so if I draw a quadrilateral here and a diagonal, I've created 2 triangles. Each one of those triangles has 180 degrees, and 180 plus 180 is 360. So a quadrilateral has 2 triangles. We don't want to draw a second diagonal because you don't want your diagonals to intersect. We want to keep them just one. We don't want them to crisscross. Alright, and if we did the same thing with the pentagon, we draw 5 sides. We would say, well, how many diagonals do we have? Alright, so we would not want to draw too many so that they intersect. So I'm going to draw a diagonal here and a diagonal here. Each triangle, there's 3 of them, so I've got 3 triangles in a pentagon. Each one has 180 degrees. And if I were to add up 180 plus 180 plus 180, I would get 540 degrees. Alright, so now we can do that with every single one of these, but it would be better if we could just kind of see this pattern going. And if you notice, however many sides we have, we subtract 2 and we get the number of triangles. 4 sides to a quadrilateral, 2 triangles. 5 sides to a quadrilateral, 3 triangles. Each time we add a side, we add a triangle. So let's go ahead and add a triangle here. Now be careful because we're skipping, and we skipped 11 because we didn't put 11 on here, and we're going to have 10 triangles in there. Well, if we know how many degrees there are in the previous polygon, we just add 180 degrees to get to that to get the next number, because we're adding an extra triangle, so we add an extra 180 degrees. So if it is a hexagon, 6-sided, 4 triangles, we're going to have 720 degrees. Heptagon will have 180 more, giving us 900. Then 1080. 1260, 1440, then 1800. Okay, now notice I left this blank. Let's fill that in. If the number of triangles is 2 less than the number of sides, what would we put down here for the number of triangles in an n-gon? Well, it's the number of sides minus 2. So it's n minus 2. Now, let's get a formula to figure out how to find how many angles there are, or how many degrees there are in a particular polygon. The formula for this would be 180 times however many triangles there are. So in a triangle, you have 1 times 180. In a heptagon, you have 180 times 5. So what you want to do to finish this out is take 180 times the difference of the number of sides and 2. And that is the formula for finding the sum of the interior angles. Now, exterior angle sum. We're going to be discussing this more on the back page, but I want you to know it does not matter how many sides there are to a convex polygon. All of the exterior angles will add up to 360 degrees every single time. What happens is as you add a side to each polygon, the interior angles become more obtuse and the exterior angles become more acute. So you will constantly always get a total of 360 degrees out there. And we're going to draw a picture on the back side so you can understand what that means. So flip over your notes, and on the back side we will continue with the interior angle sum theorem. And basically that's the formula we just came up with in the table on the other side. The sum of the angles, S, is equal to 180 times the difference of the number of sides and 2. So we want to be sure and label these so you know that n is the number of sides and S is the sum of the interior angles, and I just abbreviated interior. Okay? Now we're going to draw a little picture in this box of a pentagon, and it's not a really big box, but we're going to do our best to get a regular pentagon in there. Okay, and what I'm going to do is I'm going to use this formula to figure it out. So we have 180. It's 5-sided, so we're going to put 5 where n is, minus 2. So then you end up with 180 times 3. 180 times 3 is 540. All right, so you've got 540 degrees total for this pentagon. Okay, I'm going to stop right there and then we're going to do some more to it in just a second. Here's your exterior angle sum theorem. Okay, what this one states is that the sum of the exterior angles is always 360, just like I told you on the front side of the notes. Okay? Always 360 degrees. All right. So, if we want to find out how many degrees each interior angle has, what we're going to do is write a little formula. The interior angle formula is equal to 180 parentheses n minus 2 divided by n. Alright, so notice this top part is nothing more than finding the total degrees, the sum of the interior angles of a polygon. The last step I need to do here is I have that total, but I need to divide by how many sides there are. If I take 540 and divide it by 5, I'm going to get 108 degrees. So every angle is 108 degrees, and they are all the same. Now, to find the exterior, the degree of the exterior angle, this formula is nothing more than taking 360 degrees and divide it by how many sides there are. Since the sum of all exterior angles are 360, no matter what the polygon is, we just divide it by the number of sides. So, in this for this pentagon up here, the exterior angle is equal to 360 divided by 5, and that gives us 72 degrees. Alright, so up here in this pentagon, if I go ahead and extend all of these sides out, all of these exterior angles are going to be 72 degrees. Now, I want to see if anybody picked up on this. What do you notice about the exterior angle and the interior angle? They add up to 180 degrees. 72 plus 108. So your interior and exterior angles are supplementary. That goes back to first semester. Angles that add up to 180 degrees. Alright, so if we want to find an interior angle, we can easily find the exterior angle and subtract it from 180. So that's a little hint that can help you out, or vice versa. If you know the inner angle, subtract it from 180, and that gives you the exterior. But exterior is a little bit easier to find, because if you know how many sides there are, just divide 360 by the number of sides. Okay? So if we want to draw that picture here, that little hint here, 72 and 108, we could have 180 minus 72, that gives us 108, or 180 minus 108 gives us 72. So we can go either way. If we know an interior, it's easy to find an exterior, and vice versa. Okay, the last part of the notes. You've got a picture here, and in the figure, all the interior angles are congruent. So all of these are the same. Okay, and we have an 8-sided figure, which is called a polygon. And what we want to do is find the measure of each exterior angle. Alright, so what formula are we going to use? The exterior angle formula. 360 divided by the number of sides. So, to find an exterior angle, we're going to take 360 and divide it by 8, and we get 45 degrees. Oh, well then an exterior angle is 45. So what can I do real easy to find an interior angle? Well, since they are supplementary, 180 minus 45, and that gives me 135 degrees. So each interior angle is 135 degrees. So you can use several different ways you can approach these problems several different ways. This is one of the easier methods. Alright, so it concludes our notes for 8.1. I hope that it went well, and thank you very much for listening.